Hello, welcome to another stream. How about that? How about that? Oh, but you didn't expect that shit to happen. Hello everyone, today is Saturday, not Thursday. Oh, excuse me. Thursday. Today is Saturday, and that means today, according to the schedule, we're supposed to be doing game development, but yesterday we started an interesting topic of doing an actual 3D graphics on OpenGL. So, it was actually kind of interesting topic. I didn't really finish it, so today I decided to make another stream with the same topic and finally finish it. So, you can find the source code of what we did yesterday in here, right? So, and today we're gonna just continue it. So let me actually open the source code and let's take a look at it. So we even had a plan there. So yeah, so the plan was to generate the cube mesh, right? The idea is to generate the cube mesh. Then they read the cube mesh with the perspective projection. We did both of the points. The next thing was to texture the cube. We did that like half the way through. We managed to lower the texture, but we didn't have enough time to properly map it onto the cube, like with the proper UV coordinates and whatnot. And the last step would be to introduce some simple lighting to the scene. So yeah, today I just wanted to continue doing that. So yes, and let me get started. So I'm gonna go to the source code and fetch the latest changes. So because I did a little bit of work off screen, I'm pretty sure. Oh yeah, I also worked off screen a little bit on the OpenGL template. I finally made it actual template, so you can find it here. So. Oh, really sorry. I'm a little bit sick yet, so I already feel much better. I don't feel like I'm already sick. I don't feel intoxicated, but I still have some, symptoms that I'm still sick with. So yeah, and I apologize for weird noises that might be doing. I finally turned this into an actual template, so we can use this template if you want to. I'm gonna definitely be using it. So this thing is just for OpenGL projects that I may start on the stream, because quite often if I need to start an OpenGL project, it's such a chore to get all of the OpenGL initialization running. It's just holy fuck. And this is not even a Vulkan yet, right? In Vulkan the situation is even worse. So you are not supposed to, as I already said, OpenGL is not supposed to be understood, it's supposed to be copy-pasted, right? So you're not supposed to understand what you're doing, you're supposed to like remember all of these commands. No, you don't remember all of that, you just copy-paste. Yeah, and that's why I got sick of constantly reinventing this entire thing. And I created OpenGL template, like, which basically just creates a very simple scene with a single quad and the vertex shader and the fragment shader. So also it has a little bit of interesting things, so that it can auto reload the shader for you if you want to. So we're not trying to commit with Bonzomatic, but it has like 200 lines of code, which is actually pretty low for this kind of thing, I think. Right, so we can take a look at that OpenGL template. OpenGL template. So let me fetch the latest things. I don't know if this works on Windows. To be fair, I didn't test it on Windows. Oh, pretty cool. It even has like the badge code template, which is quite convenient. Alright, let's rebuild everything, and yeah, I'm just thinking how I'm gonna do all that. I think I want to open the thing in Emacs. So, and then I'm gonna run. There we go. So here's the test. So here's an interesting thing. The shaders have an access to at least, I think, 2 uniforms in right now. They have an access to the resolution and they have an access to time. Time is the amount of time in seconds that has passed since the beginning of the application, you can use this time to animate something in the fragment shader. For example, it's just a demonstration, right? And at any point, for example, you can change something here, right, vector 4.0, so I suppose it's going to become black, and there you go. You can automatically reload it without recompiling anything, and all of that is just 200 lines of code. So yeah, this is a template that you can just use to start a new OpenGL project, and it's quite convenient, I think. So yeah, if you have an error, for example, and you try to reload it, this screen is going to become red, and you'll have to take a look at the output of the program to see what exactly happened. Okay, so you forgot a semicolon. Okay, so then you can reload it back. So, and like, I'm really proud of how small this entire thing is. Like, it's just like, you know, 200 lines of code, and all of that is just there. It's pretty cool. It's pretty cool. So yeah. And our project is based on that template. So I'm gonna keep improving it. I'm gonna keep adding things. I think I can actually cut off on some fat in here. Like, this thing is not really particularly useful. So yes. But anyway, let's take a look at what we have in the thing that we did yesterday. Right. So it's gonna be Kidito. I'm pretty sure I already fetched the latest stuff. Maybe I didn't. I'm just gonna do that just in case. Okay, so yeah, I actually removed a lot of stuff. That's kind of interesting. What did I remove there? Oh yeah, so I was actually cleaning up some of the templates and whatnot. Alright, let's rebuild that. And it's supposed to be capital B, not a singular B. Hey Hots and Pots, what's up? Welcome to the stream. How are you doing? You wanna see something cool? A cube with a really weird shading. So that's basically the result of yesterday's stream. I think this kind of shading I didn't show on the stream. So the thing with this shading, just a second, let me open the vertex shader, is that I'm using UV coordinates. So I'm using the UV coordinates as the color, which is probably not particularly correct. Alright, so I need to go to the fragment shader. If we use whatever we use for the color as the UV coordinates, we're gonna get something very, very dumb. Right, so texture, the texture is called POG, and we're using the UV coordinates, and this is how it looks like. Guess what it is? Right, so I'm using the colors as the UV coordinates. Yeah, looks very, very dumb. Yes, it is sodium POG. It is sodium POG. Oh shit, what the fuck is going on? I wanted to just open this thing here, so it's that thing. But if you take the UV coordinates, they coordinate on a texture, right, and you use those coordinates as the colors for red and blue components, in turn it turns into this kind of interesting shading. So which is interesting. Shading, interesting shading is interesting. So there's definitely something wrong with I don't even know what. Like, there's something wrong, definitely. Especially something with the maybe order, with the Z ordering or something like that. So yeah, I was thinking that maybe we're gonna troubleshoot that, but yeah. So that's the result of the previous stream, and we need to finish these last 2 points: texture the cube and simple lighting. We kind of textured it, right? But the point didn't specify how exactly we have to texture it, right? So there is a texture somewhere there, you can see it. But I mean, it's just kind of dumb. So anyways, I'm just thinking what we're gonna do. I wanted to try to rotate the mesh without the matrices, right? Without the matrices, because what we're doing, we're just rotating around the y-axis, right? So, and essentially, if you want to rotate something, for example, around the z-axis, if you want to rotate something, maybe I will be able to get rid of the matrices altogether, because to be fair, matrices, like, you can like write a whole game, a whole simple game without using matrices at all, right? Matrices don't enable you something that you cannot do yourself manually. They don't. They're not like magical things. They're a way to encode operations, right? They're just like a compression format. Right, it's a format of describing operations. Like you can take several operations and just can compress them into a single matrix and just apply them all at once. So the reason why you can do that, by the way, is that because the operations that the matrix can encode are sort of cancel each other out. That's why they're compressible. But who said that to compress them like that, you have to explicitly use matrices? You don't have to. Right, so it's kind of interesting. It's more of a hack than the like the actually, you know, super important thing. But I mean, everyone's using them. We have a lot of like mathematical framework built around them. We have a lot of programming frameworks built around them. So it's just more convenient to use it right now. But there's nothing special at the core of matrices that makes them irreplaceable. I think you don't have to use them all the time. Matrices, aka the wet dream of every mathematician. Yeah, I guess. I'm not speaking for the whole math, by the way. I'm pretty sure there's like some branches of math where it's important. But specifically in the computer graphics, like I couldn't find a place where I just couldn't replace a matrix computations. I could easily get rid of them because they're just a way of encoding things. Alright, it just depends on what you're doing. But yeah. Quaternions, yeah, quaternions are fun. I still need to learn about rotors. People say that rotors are better than quaternions, but like I need to read about them more and understand them more. So what I want you to say, essentially, to rotate, like you have an X and Y coordinates, right? I really like this shade of pink, by the way. I think it's cool. I really like this bright pink on a dark background. I don't know. Makes me very emotional. So here's the X and here's the Y, and you have a point somewhere here, right? You have a point somewhere here, and you want to rotate that point, right? Emo, maybe, yeah. Who knows? 2007. In 2007, I was 17, and I was not emo, by the way. So when I was a teenager, I wasn't part of any sort of like these groups of interesting people, I would say. So I don't know. Anyway, so you want to rotate this entire shit, right? You want to rotate this entire shit, and how would you do that, right? So if you're using Cartesian coordinates, right? If you're using Cartesian coordinates, so you said that, and now my brain tries to picture how that emote is gonna look like. It's probably starting W with the hair. Anyway, so in the Cartesian coordinates, it's kind of difficult to do that, right? So you can easily rotate them if the vector is in what coordinates? Radial coordinates? I keep forgetting about what's the name, and it starts with R. It starts with R. Polar. R, it's at the end. Okay, so I'm sorry. I don't know why, like my brain just moved R from the end of the word to the beginning of the word. So yeah, it's... Oh, maybe this is because P is actually Cyrillic R. So that's probably why. Yeah, okay, you guys got it. Maybe. Anyways, so if we translate that to a polar coordinates where you have, you know, an angle and the magnitude. How do you describe the magnitude? Oh, let's call it R for the radius. Rotating that vector is as simple as adding that angle to theta, right? So essentially, if you want to rotate the two-dimensional vector around the imaginary like z-axis here, what you do, you take the vector in Cartesian coordinates, turn them into the polar coordinates, add to the angle and convert them back. So, and what's interesting is that if you go through the math, you will probably end up with a very simple formula, which is the result of matrix multiplication with a vector. So yeah, which further confirms my point. So maybe that's exactly what we're gonna do. So let me try to see. So imagine that you have x and y, right? You have x and y, and you have an angle alpha by which you want to rotate it. I was taught to derive the rotation matrices like this, like, wow, you're talking about that? Okay. So, yeah, well, did you just join? We were discussing it for quite some time. Okay, so we have this alpha. And so what's going to be theta? So I'm pretty sure it's going to be a tan 2, right? So if I remember correctly, it's going to be a tan 2, electric boogaloo, a tan 2, y over x, and it's going to give us an angle, right? So, and the size, yeah, I think I'm not gonna go really far with that. I think I'm not gonna go really far with that. It's phi, not theta. Oh, okay, I'm sorry. Oh yeah, I keep confusing them. Yeah, whatever. So, how do you know the length of the vector? How do you know the length of the vector? Well, you just use the usual shit. So something like that. So then you add alpha, and you need to convert it back, right? So how do we convert everything back? So this one is gonna be x is cosine, right? R cosine that, phi, r is a sine, like that. Cool. So what's interesting is that if you want to have a rotated version of these things, right, a rotated version by alpha, what you're going to end up with is this r. Let's actually put it like this. It's going to be probably x plus y multiplied by cosine of, yeah, a tan 2 y over x plus alpha, and the same goes for y, I suppose. X plus y sine. Yeah, that's how we do that. Cool, isn't it? So interestingly enough, I don't have enough knowledge to actually simplify this formula. So some of the things I can probably Google up. Alright, for example, what's cosine a plus b, right? So it's probably equal to something very smart, which people figure out. The same goes for sine a plus b, right? So, and interestingly enough, what's the a tan 2 exactly? We might take a look at the definition of a tan 2. So equivalence does not always hold, whereas R, it returns the single angle such as and for some, okay, it's basically arctangles. Like generally, you can think of it as an arctangent. I'm sorry, I'm Russian. I don't speak English. And yeah, so essentially this is basically just, you know, going through all of these formulas and remembering how to transform all of that. And this is something that is kind of boring for me, and I'm not really interested in that, but I generally have this idea, right? So this is, by the way, I was so bad at math in school. It's not because I didn't understand it. I understood it, and I usually reach the point where, oh yeah, you just need to do that routine thing that is not interesting by anyone by looking and remembering these things. So yeah, I solved it. I'm not interested. And I always get bad grades for that, because you're supposed to fucking do that boring shit. No, if you don't do that boring shit, you don't understand it. But I do understand it, I just don't want to do that. Like I just don't want to do that. No, if you don't do that stupid, boring fucking shit, you don't understand it. You just don't fucking understand it. There's no way for you to prove that you do understand it if you don't do that stupid fucking shit. Oh, sure, like, yeah. That's why, for example, school grades mean nothing to me. So if some person comes to me and says that they had a good university or school grade, that just means literally nothing to me. This just means that you're willing to go through that stupid boring shit. So, and I'm happy for you. So you can work at a place where people expect you to do stupid boring shit. Congratulations, you just proved that you can do that. So anyway, but maybe I'm saying all of that because I'm a loser and I'm just justifying, you know, trying to justify my stupidity. So who knows? But what's interesting is that I do remember that you end up with a very simple formula where it's literally like x. Just a second. I already actually removed everything, but I do remember that you end up with something like x prime equal to some sort of a sign. How? Yeah, so I want to denote something like cosine or sine. Right, so basically cosine or sine, I'm going to denote them as sun, right? So you end up with formula that is like plus minus sun, I think alpha multiplied by x plus minus sun alpha multiplied by y, and y also ends up being something sun alpha x plus minus sun y. So basically, yeah, if you go through all of that boring stupid shit, you're gonna roughly end up with something like this. It's gonna be somewhere there is gonna be plus minus something, and somewhere there is gonna be either sine or cosine. I don't remember for sure. So yeah, so we just invented a new notation, by the way. So you know, notation for plus minuses means it's either plus or minus, and sun is basically either cosine or sine, but we don't remember that. You can derive that from matrix version. Yeah, but it's kind of like you essentially decode what's encoded within the matrix instead of actually coming up with that yourself. Are you winning, son? Yeah. Okay. Oh shit. I closed the chat. I didn't mean to. Let's call it a happy little accident and continue just working whatever we're working. Okay, so I'm just joking. So all right. Streamer don't like us. Well, I mean, everybody complaining about streamer don't liking them, but does anyone like the streamer? So, anyways, rotate vector by angle formula. rotating a vector revisited. There's a 3 minutes YouTube video. Are we gonna watch it? Are we gonna watch it? Let's watch it.
This week by motivating linear transformations by looking at a rotation. What I'm now going to show you is how to compute the matrix that represents a rotation.
Next one. Rotating vector in rotate vector in 2D. Yeah. Where is the music? Oh fuck! I closed. I was focused on the wrong thing. All right. So I guess that's how we do that, right? So it's gonna be... Oh yeah, so as you can see I was right, it was something like that. So we may try to now continue that. So how can we test all of this? How can we test all of this? So what is this? Yeah, this one. This one. Start calculator. What we can put here? What we can put in here? So x. This is the formula. I'm gonna spend more time actually learning this shit than I would like to. Okay, x is equal like 5 and y is equal 6. And I would like to turn it into a formula, into a vector, but I don't know how to do that. So I'll probably have to do something so it's easy to code that, like then learn this piece of software. Vector. Points and vectors. Okay, let's take a look at the manual. This doesn't help. What the fuck is this shit? I guess you have to do something like V. Oh, holy shit, this is so slow. Okay, I guess that's how you do that. So this is a vector. And then we're gonna have some sort of an angle. It's already taken, so let's actually put angle like 90 degrees, I suppose. All right, and you can, it's from, well, that's okay, I suppose. You can control that, and then you can define a vector like this. Vector prime. Can I define it as vector prime? Right. So, and if I take a look at this thing, so this is gonna be, oh, this is so bad. I cannot just split everything and, yeah, I literally have to do that on a separate text editor. On a separate text editor. So I suppose, can I actually access a separate component of this thing, like X? I cannot. All right. So maybe I can access it as this. Is it possible to access it? No. Huh. Okay. So maybe it's written somewhere there. So I have a vector. Oh, you use it as a function, I see. So you have to do something like X. Yeah. Okay, so this is how you access all of that. That makes sense. All right, so I think I have enough. So V prime is going to be V of X, right? And it just depends on the formula here. is going to be multiplied by cosine of that A angle minus, it was actually this, right, minus YV of sine angle. All right, so this is the first thing, and then I can put it like that, and this one has to be a sine plus cosine, right? So this is going to be the second thing that we need to do, right? And there we go. And that didn't work. Yes, I'm so happy. And I wonder why. Okay, so we have that. And no matter, well, oh, that's very interesting. Oh, this is because it's in radians. Yeah. All right, so maybe if I add, how can I add another one? And okay, so I want to be the angle to be like a value. Oh, can I make it like 0, 0, 1? All right, and ranges to be in this particular, so in some situations it's just like really strange. But yeah, overall I think it works. I think it actually works. So I just need to learn how to, so it has settings, right? So definition is that fixed object slider minimum maximum. Let's actually make the minimum from 0 to 2 pi, right? Can I do something like 2 pi? Fixed random speed is gonna be 0, 0, 1 because it's too fast, right? So will it work now? Yes, this is, and okay, so that's fine, I guess. Yeah. All right, I managed to make it work, and we managed to test the formula. Perfect. Perfect. So that's pretty cool. Maybe I'm gonna start using this thing. I'm gonna start using this thing a little bit more because it doesn't really look that bad. So I can test some hypotheses really quick. What's up, Cloud9? All right. So maybe I'm gonna try to use that. But what's interesting is that since we are rotating not XY, we're rotating rather XZ, right? So instead of Y, we have to use Z, but it's still gonna make it rotate properly. I should definitely go through that stupid boring shit of arctangents and stuff like that to come up with that formula myself one day, but I definitely have to do that off screen. All right. So maybe I need to make another cup of tea. But the idea here is that I want to make the angle. Actually, I don't really care about the angle. We might as well just accept a uniform float time as we do in the original OpenGL template, right? In the original OpenGL template. Right, so here, for example, the colors are computed with the sine waves, and as an angle we use the time. So maybe the similar thing we're gonna do with the rotation, right? So instead of an angle, we're gonna use time, and yeah, we're not gonna even pass any matrices to the GPU. So we're gonna only pass time, and all the computations are gonna be done there. Right, I think that's gonna be cool, and will eliminate the need for matrices completely. So, all right, let's try to code that, I suppose. Let's try to code that. Where's my water? Oh shit, I need to refill my water. Just a second. So let's make a small break, chat. Let's make a small break. It's gonna be like a 2 minutes break. 2 minutes break. And there we go. And you guys have fun. So I forgot to pour myself like a bottle of water, and yeah. Yo, what's up? I'm back. So let's try to have this uniform in the program. So where is the program? Global program, I mean. So here's the program failed. Oh, by the way, I think I want to keep all of these uniforms at the top because, yeah, what's interesting is that if I reload the program, I think it will kind of stop working, but not really. Yeah, I'll have to get the location one more time yet again. Yeah. So let me put this entire thing somewhere here. So I'm using global variables, by the way, chat. Please tell me that I'm a bad programmer. Tell me how wrong I am for using global variables. So, do I have any other uniforms in the fragment shader? So I have POG, but I'm using that just a default value. Okay, so that should be fine. Right, after we reloaded the shader, I'm gonna do U matrix. Vertex. GL get uniform location program. Might as well actually do that after we use the program, just in case. And this is going to be a matrix. There we go. It's called matrix location. So another thing I want to have is time location. Okay, so here's the time. So let me try to compile and see all of the mistakes I've done. We don't need that stuff anymore. So this is a matrix location. Cool. Alright. So in if I try to run it one more time, so it does work. It seems to be working. It seems to be working. It seems to be twerking. So I need to have the position. I need to have the position. So vec4. Yeah, it's just gonna be called the original position. So this is the old code that I'm gonna be sort of like using as a reference, but I'm gonna recreate it. Is it possible to use const in here? Well, GLSL mod highlights it, so I assume that you can. So, what's the next thing? So, we're gonna use something as an angle, alright. So this is the formula. We have, we use x. I think I'm gonna just copy paste this code. But maybe making a const is not gonna make much sense. Position x is gonna be position x. Let's rename it to just pose, because position is too much to type. Okay, so it's going to be pose x and pose y. CS is going to be the cosine. And what we're going to use as an angle, let's actually use something like 0. Let's use 0 for now. And see that it does not rotate. Alright, so this is the rotation. Rotation, there we go. Then we need to do the projection. Right, we need to do the projection. Projection should be pretty straightforward. Projection, so we take the position x and we divide it by position z. like this. And that replaces all of this shit. So, and then we say GL, what was that? GL vertex? GL position, yes, it was GL position. GL position equal to the position. Maybe I could just inline. There we go. So here's the input position. So we fix it up, then we rotate it, then we project it, and then we assign it back. And also we need to provide the like a texture output. Right, so this is the output, so this is the actual output vertex, and this is for the UV coordinates of the texture. So yeah, right now it seems to be working. How am I doing today? I'm doing fine, I guess. Thank you for asking. A little bit tired, but this is because I'm still a little bit sick. So yeah. Cheers. All right. So, and all right, so it doesn't work. Nice. Yeah, I hope so as well. I mean, I already feel better, so I'm recovering. I'm steadily recovering. That is very strange. So in the original code, I also made it smaller. All right. So I fixed it up, I reduced it, and also after I rotated it, I moved it more far away. I see. Alright, so that kind of makes sense. So after the fix up, I think one of the things we want to do something like this. Okay, so that kind of worked. Oh, wait a second. It is rotating. Oh, the coordinates are, the UV coordinates are actually changing over time. So yeah. So let's actually not. Let's just use the original position then here. Let's just use the original position. And something went wrong. Oh yeah, it's one of the... It optimized out the uniform. Holy shit. And people defend this API. Ironically. Yeah, I wanted to remove that anyway, so might as well just, you know, remove matrix location completely. Just remove matrix location completely. Defenders. Imagine being a defender. Oh yeah, and it still compiles, and also probably have some other mistakes. So UV has a different. Yeah, UV has a different. So I have to use like XW. Okay, so that's cool. And I think I think that's reasonable. So, no, let's actually not remove. Is there any alternative? Yeah, there is no alternative. That's why I have to defend that shady API. Yes. How does that make sense in your head? Like, really? For you, if there's no alternative, you have to defend a shady API. Holy shit. So let's put this thing like that, so this is going to be a 0. Okay, so if I slightly increase it, oh, that's very interesting. Yes, it is working. It is working, it is twerking. Holy shit. Yes, sir. But something wrong is with this kind of thing. Okay. So now I want to rotate it around like the around y. So that means in my case, x is gonna stay x, but z is gonna become y. Yeah. So we have to do it like this then. Yeah. I think that will work, but it kind of doesn't. It kind of doesn't, right? So, yeah. Something is completely broken. Oh shit. Okay, I'm an idiot. Okay. 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 So I also do that, and yeah, I obviously made a mistake here. So, and I probably want to actually move it slightly away like this. So now, what if I use time instead of a? Yeah, so we don't pass time yet, so that's kind of the problem. GLFW time. Okay. I guess this is how we set all of that. Okay. Angle is not needed anymore. Yep. I think that's fair. It's just the problem, the entire thing is too big, so we have to make it a little bit smaller, I think. We have to make it a little bit smaller. I wonder which way is gonna be better. Okay, so we prepared this entire stuff. So this is a fix sub, but on top of that, I want to divide this by vec4, maybe multiply it as well. So another fix sub, but this one is going to be just 1. And did it do anything? I don't think so. It didn't improve anything. I wanted to move it away. So if I try to move it away like that, yeah, negative is not gonna work that well. What about 2? Yeah. But overall, I think it seems to be working. It's just like, I'm trying to make it smaller, so it's not like... yeah. Oh shit, I'm an idiot. Oh my god. Oh my god. 0. -1, but plus like 1 in here. What about +2? So it's rotating in a completely... yeah, okay. So that means you have to move that after you... okay, that starts to make sense. So you first rotate, then you translate. Translate. And this is gonna be pose x, not z, but x. Z. Plus like 1. Yes, finally. Why? Yeah. I know why. I know why it took me so much time, but yeah. I'm not using any matrices right now, so that's kind of cool. I'm not using any matrices. So now we can go to the fragment shader and, for example, set the color to something vec4 like 1 0 0 0 1. Right, so it's gonna be completely red. And so here, for example, I use UV coordinates, right, as the color. And if I try to use UV coordinates for the texture, so yeah, you can see what happens essentially. But this is more expectable than what I had yesterday. That makes sense. That kind of makes sense, I think. So use. We can even like mix between the UV coordinate color and all of that. So if I mix between this and that with like 75%, and it gives me that filter, we can even do something interesting. So can I have an access to the time? I'm pretty sure I can have an access to the time. So, and in time, I can do a sine of time, but sine is from -1 to 1, so that means I need to add +1, right? It's going to be from 0 to 2, but we need from 0 and 1, so I need to divide it by 2. And that will sort of like change the colors, I think, over time, right? Yeah, it's just like, yeah, it's dumb. Yeah, it's dumb. So yeah, it's Sodium Pride. We needed Sodium Pride mod, by the way. We needed Sodium Pride. Yeah. So which Sodium mod has to be Sodium Pride? I think I suggest Smug. I think Smug is actually perfect for Sodium Pride. All right. Anyways, no Sodium Gachi. It is what it is. All right. So I think this is great. Now we're doing pretty epic 3D graphics without linear algebra. By the way, speaking of, we're doing 3D graphics without linear algebra. Who would have fucking thought? I guess I am actually debating people into linear algebra. Anyways, okay. So let me do a committee. I kind of like prefer this kind of way, like a little bit better. I don't know. Matrices kind of make me sad. debated me into linear algebra. Yes. I'm sorry. Oh shit, I'm sorry. It's a good question, MVP. I have no idea. This is such a good question. How do you translate that in English? Does anyone have any ideas? So specifically this verb. So this is a single verb that means grew too much hair. How do you say something like that with a single verb in English? Does anyone know? This is actually pretty convenient. Yeah, it's a pretty convenient Russian verb that basically says that grew too much hair, overgrown. Maybe, but overgrown means that maybe like I grew up too much, like generally. Hairy, no, hairy is an adjective, but this is a verb. That's what's interesting. Now we need this as an emote. Let me check it out. Well, I mean, I don't have that many slots left. I can probably add it to Discord. I don't have slots on Discord either. I will probably have to add it to BTTV. So, but BTTV is like so did J. Oh, okay. Wait a second. Okay, I will add it to BTTV. Okay, this is the best I can do right now. Sodium JL. Fucking perfect. So what's the size of this? Oh, it's okay. Let's do convert. Convert. I think this is how you do that. Oh, a minus I is for FFmpeg. Yeah. So the flags of FFmpeg and image magic actually mixed up in my brain. So, so it's something like this, and it's gonna be sodium one PNG. We're gonna convert it to PNG. Okay. Okay. So that looks good. So BTTV. Dashboard. Upload emotes. Can I drag and drop this shit there? I pay $5 every month to this server. Can I drag and drop this shit in here? I cannot. What am I paying $5 for every goddamn month? I sound like an average Sojing subscriber. Yeah. Anyway, so let me see. 1 PNG. Sodium JL. Based on the original work of mine. I guess it's technically true. Sharing is caring. Okay, so we're gonna allow sharing that. Okay, and let's just upload emote. Upload emote. Cool. So is it automatically available? Is it automatically available? Reload channel modes. It's actually F5. Okay, Sodium JL. Cool. Perfect. Thank you so much. This is at Sodium JL. I see buys. Okay. Or rather, I see JL. I see OpenGL. Let's make a cup of tea, I suppose. Yeah, bruh, is not. I think my bot is dead. My bot is dead. soon it's gonna be replaced by a new bot written in C. Oh, by the way, have you guys seen my latest tweet on Twitter? By the way, follow me on Twitter. I'm a streamer. You're supposed to follow me on Twitter. So I was experimenting with my new bot, and this is what I came up with. Pog110. Yes. So check it out. Pog110. Unfortunately, I already removed the code because it was very, like, it's written in C, right? It was written in C, and I was scared that it's like really unsafe, and I didn't leave it out. And I don't know, I will have to re-implement it one more time again at some point. So yeah, there we go. Pog110. Beautiful. Yeah, thank you so much. I'm so proud of it. So the C bot that we written some time ago actually responds to Twitch pings already. It parses IRC messages. I like how it was yes, you exposed. So let me see. What is it called? KGBotka 2. Yeah, so it's called KGBotka 2. Eclectic Boogaloo. So yeah, there we go. And I parse IRC messages manually, and I'm super scared of it actually. Because I don't know what kind of vulnerabilities are there, because you can at some point overflow the buffer into which we're like collecting messages and whatnot. So yeah. But we respond to these things, and I parse IRC messages in sort of like immediate mode, right? So I process the IRC arguments as soon as I managed to parse them. I made a PR for the bot. Okay, did you find vulnerability and you fixed it? Let me see. Oh yeah, I actually asked for like some help in README. Yeah. Thank you so much. Somebody actually reads README. Holy shit. Edit build options for compile with both OpenSSL and LibreSSL libraries implementing. Nice. That's a lot of changes actually. TLS imp right? Okay. Oh, basically you just replaced and you introduced the. You also commented out that stuff for some reason. I don't know why. That's really strange. So that's a lot of code. So you basically abstract it away from OpenSSL. I thought LibreSSL was like a drop-in replacement for OpenSSL in some cases. Is it not? That's really strange. All right, I'll have to look at that a little bit deeper because like it's kind of strange. But thank you for submitting the pull request. How do I make it mark as unread? I'll probably have to go here. Oh, it's already closed. Did I close it or who closed it? Okay. So there are two of them. I'm confused. What is going on? Okay, I will take a look at both of them, alright? I'll take a look at both of them, but a little bit later. So... OpenSSL sucks, but not as bad as LibreSSL. What's wrong with LibreSSL? So in which sense it sucks? I'm actually really curious. So because as far as I know, OpenSSL sucks in terms of the vulnerabilities, right? So the developers of LibreSSL claim that there's less vulnerabilities there, so that means it's not compatible. Oh, okay. That makes sense, yeah. Okay. Because from OpenBSD people. Yeah. I think compatibility with OpenSSL in some sense is very important for security. You know why? Why I think so? Because, okay, imagine that you made a more secure library. But nobody's gonna adapt it if it's not compatible with the current legacy code base that uses the previous API. Thus, the security, like on average, is gonna stay the same. No matter how secure your library is, if nobody adapts your library, it doesn't affect security on the whole. Yeah. It's like with Rust, right? So obviously, like applications written in Rust, they don't suffer from the common class of vulnerabilities. But if you annoy the shit out of C and C++ developers to the point that they don't want to adapt Rust, you don't improve security on average. It's like the same situation, absolutely. Right. So if you want to make a more secure language, don't annoy the shit out of people who can adapt your language. So yeah. OpenGL is pretty much the industry standard. You cannot compete with it in its section. Yeah. How is LibreSSL not compatible? This is a good question. I don't know how. I don't know. I don't have enough knowledge to actually answer that. But I would expect it to be compatible because I thought it's sort of like a drop-in replacement. But still, in the pull request, we have to make some sort of a compatibility layer that abstracts away from both LibreSSL and OpenSSL. And I don't know how, so I'll need to look into that. So I'll try to research this topic and see what we can do here. Because I would like to just make a minimal changes and be compatible with both OpenSSL and LibreSSL. But if it's not possible, well, we'll see what we can do. We'll see what we can do. Void Linux. The previous announced OpenGL switch is now underway because OpenGL's dependency of a large number of packages. Yeah, that's what I was talking about. Interesting. I see. Anyways, so what we were doing. Did I do a committee? I think I did. So we got rid of the matrices, right? So, and I think I might as well actually get rid of the matrices from the gel.h, but maybe we'll need them in the future, who knows. I definitely don't need a standard projection because I never managed to make it work. The rotation matrices did work at the end, so I'm gonna keep them. I'm gonna generally keep them. All right. So get rid of the linear algebra in my Christian 3D graphics. All right, so let's push that right into the repo. You can find the source code that I'm working on right now in here. And let's take a look at the application that we developed one more time and admire this beautiful, beautiful site. I think it's goddamn fucking beautiful. Algebra. Algebra. ICGL. Solid GL. Yes. So one of the things I want to do, I want to try to see if we don't have any fucky-wacky situation with the z-axis. So to do that, I think I want to assign different like colors to different faces of the cube and see if the back face shines through the front face when you know, when we render and everything. So, and if it does, we should be able to quickly fix that with like z buffers and whatnot. Like I think you will need to enable them at some point. So, but the question is, how can we have the color buffer? Right. So we have a special function, so buffer, for creating a buffer. So you can create a buffer out of the mesh, right? out of the mesh, but we also want to create a buffer out of the, for instance, yeah, out of the color, right? So we want to have like a separate thing, but for each individual color of the vertices. It should be relatively easy to do, because how we generate the cube mesh. So first we generate the cube face, and we add that cube face to the mesh. And maybe we can output the color as well. Why not? I think that would be kind of cool. Okay, let's introduce some interesting thing. I'm gonna do rgba.h, and let's introduce types for working with the colors. Right, so it's gonna be rgba.h, and we're gonna define this shite like that. Type def struct rect. Yeah, let's call it RGBA, I suppose. Float RGBA, right? And do we need anything else in here? I'm not quite sure. We'll probably need some sort of constructors and whatnot, but I don't really plan to add any transformation operations on RGB. We can add them later as we need them. Well, you know what? Since in vectors we use the arrays, I think it would make sense to use arrays here as well. Is it PRC, not C++? Why? To know why, you have to donate or subscribe. The reason why I'm using PRC and not C++ is an exclusive content under the paywall because of its demand. There's too much demand on expressing my opinion about C versus C++. That's why it costs money. I'm really sorry. There's nothing I can do about that. So yeah, if you want to know my opinion about why I use C and not C++, it's just, it's a donor wall. We need a mod for donor wall. Okay. Because everyone asking that, and I'm tired of explaining that over and over again, so I decided, you know what, if there's so much demand on this kind of content, paywall. It is what it is, and it isn't what it isn't. The same with why not Rust, and the same with why not Vulkan. Like we talked about it way too many times, so sorry, I'm not talking about that anymore. All right. But what about Zeke? Oh, Zeke holds a special place in my heart. Trust me. The best way to promote your language is to annoy the shit out of the people who may potentially adopt it. Such a nice strategy. Holy shit. It's such a perfect strategy. It worked for Rust, it will work for Zeke. Yes, just annoy the shit out of the people who can actually adapt your language and do something interesting in it. Yeah, go ahead. That's perfect. That's fucking perfect. Anyways, so RGBA comps, right? So we're gonna have the amount of components. Why C and not basic? People usually don't ask this kind of question. Let's actually think. The main reason why I don't use basic, and by the way, which basic do you mean? So there's a lot of different basics. Is that because I don't know basic? Basic was never my first language. For a lot of developers, like old school developers, basic was their first language because of like Commodore or something. I don't know, I never had it. So, but yeah. Though, my first programming language was Visual Basic 6, like first real programming language. I had programming languages before that, but they were merely Turing complete systems, not really programming languages. So yeah. But my first real programming language was Visual Basic 6, and it doesn't really work that well on the environment that I'm working on right now, so I don't know. QBasic. Alright, so let's define RGBA. RGBA comps is gonna be 4. Okay, Starting with VBA, where the editor would pop up in model dialog, every type you had an error. Okay. Oh yeah, I see what you mean. Extremely stupid question, but if you want to rotate and scale a matrix, why do you do it the opposite way? First scale and second rotate. This is a good question. So this is because you're using matrices, and matrices actually obscure what exactly going on. And this is, by the way, the reason why I don't really like the matrices. I'm not saying they're bad, they're like have their uses and they make a pretty convenient code, like they allow you to compress the separation, but they really hide away from you what exactly is going on, and you start asking questions like, why the fuck do I have to do that in a very particular order, right? So again, so you probably maybe just joined, but we already discussed what does it mean to rotate something, right? What does it mean to rotate something? So essentially, when you're rotating a point, you're rotating it around like a particular axis, or like in two-dimensional space, it's around this particular point. So you rotate it like that, right? So there you go, you rotated a point. If you have an object, right? If you have an object, you probably want to center that object at the pivot of rotation, right? So you have this sort of like a rectangle, and if you want to rotate the rectangle, you take each point, right, like this, and you rotate each point, right? And thus you rotate the cube. Right. So in case of a scale, it's probably not going to affect that much. But here is the thing. If you do, for example, translation first, right? If you first translated your vector here, and then you're trying to rotate, you're going to end up with the situation like this. So you translated it, you moved it away from the center, and now you're trying to rotate. What in fact you're rotating points like this, you're rotating these vectors, right? So yeah. So, and when you try to rotate, you basically rotate the square like this, right? So you moved it like somewhere here, right? So to understand why you actually have to apply matrices in a particular order, try to think of them not in terms of matrices, but rather the operations that's going on a level of a particular point, right? So what's going on with a particular point? So translation is just moving the point from one place to another. Rotation is when you treat the point as a vector and you rotate it like that. Scaling is when you're moving the point away from the center. If you start thinking about this kind of operations in terms of these three basic operations on a single point, you will start to understand why you have to apply them in a very specific order. Does it make sense? That's why I don't really like. I think like matrices are very important. They're very useful, but they're not very pedagogical because they don't explain a lot of things. So it doesn't make sense. Okay, cool. That means I explained it really well. That does make a bit of sense, but it definitely needs a lot of more practice. Yeah, probably. So you have to train your brain to think, I guess, in a particular way. I don't know. I'm not a computer graphics engineer, so I know nothing about that stuff. So maybe I'm not even qualified to answer these questions. So, anyways, I tried to explain. Obviously, I failed. I'm very sorry. It is what it is. So we have a RGBA. So when I'm generating a mesh for the cube, I think I need to generate the colors along with the points. So that's why we're going to do the following thing. So we have triangles per cube. All right. So So I'm gonna do something like colors. Here's the triangles per cube, and for each triangle, yeah, we have to have a like 3 colors for each of the point. For each of the point, and that means we have to do 3 vertices in here. 3 vertices. All right, so let's try to recompile this entire stuff. So, and now, every time we're pushing the cube face, we also have to push some color into that thing. But we need to have colors. What kind of colors can we use? So we can use a set of predefined colors, RGBA. Okay, so let me see. So RGBA, for example, red, right? So this is going to be red, and red is essentially just this, right? So let's just define all of the colors. Red, green. I'm gonna align everything, of course. It's nice to see Zoidin finally embracing meshes instead of generating everything in the shader. So the reason why I didn't like to generate, didn't like meshes is because I didn't have enough knowledge to use them confidently. So it's not like I didn't, I thought that they're bad, I have to generate everything. No, I just don't have enough knowledge to use them confidently, that's it. So as I gain more and more knowledge and more practice, I become more and more confident and start using more and more different features, and that's basically this. All right. So what's gonna be the next one? Yellow is gonna be this thing. I'm pretty sure this is the yellow. Red plus green. Purple. I'm pretty sure it's a red plus blue. And the green plus blue is what? Cyan? I forgot. Teal. Oh yeah. Yeah. Okay, so we have like 6 colors in here, and I think that should be enough for us, because the cube has 6 faces anyway, right? So let me see, can we do something like, it's cyan, okay. 6 colors are enough for everyone, yeah. Okay, so this thing is not a really constant time thing. So what I want to do here is actually turn it into a bunch of macros, because I'm using C. And if you want to know why I'm using C and not C++, okay, do I have to wrap it around? I think I want to wrap it in parentheses just one more time, just in case. There we go, so we're gonna have this. Magenta, whatever. Bike shading. Bike shading. Chat is bike shading. I think I'm gonna actually mute the chat yet again soon. Because chat is getting very backseaty and bike shading. So let me see. I'm just thinking, like, I want to have an array of the colors when I'm generating this stuff. So here are face pairs. Might as well actually make it static and const because I don't plan to modify that. Static const RGBA. Face colors. Alright, cube faces. Cube faces, and we're gonna just use these cube faces in here. Okay, and we're gonna replace this entire stuff. Which is something's really strange. Don't really feel good for some reason. Okay, so cube faces, if I take a look at the cube faces. So its cube pairs is actually 3 and pair components. Okay, so this has to be 6. This has to be 6. Okay. So we have count. I need to make a cup of tea. My brain is actually shutting down. Oh yeah. So I think I can make a small break. So it's gonna be something like 2 minutes. Should be enough. All right. You guys have fun. Yo, what's up? Let me see what we can do now. I'm just waiting for my tea to load up. Load up. I'm loading up the tea. Okay, so the amount of faces. So this is the cube faces, cube face pairs, v4 components. All right. So you generated a mesh, and this is the triangles per face, and we have 2 of them. And for a single face, right, for a single face, we have trace per cube, 3 vertices. All right, that means we have to have like 6 of them. So it has to be trees per face. Right, this is a trees per face and multiplied by 3 vertices. And this is the amount of vertices we have on a face. So it's basically face vertices. Right, this is possible face vertices. And then here we're going to iterate through all of them. Right, so we're going to be iterating through all of them. And I forgot to do this thing. And maybe, or maybe I don't have to do it here per se. So this is going to be count plus 1, and this is going to be just a mesh count. So this is the mesh, and then we also have to add the colors. My tea is ready, by the way, so I'm just going to quickly go to the kitchen and yeah, load up my tea. Hot. Nice one, sir. You got me. 6 hot loads. Right now I think I have like a 2.27, actually 0.09. So these are my hot loads. So yeah. Disappointed that the tea kettle is not rated to send its temperature to your i3 bar. I could probably do that, but that sounds like a very boring project, to be fair. Colors. So a single mesh is a triangle, right? So it's basically a bunch of triangles. So what we can do here, I suppose, is going to be count. And we have to multiply it by 3 vertices, right? 3 vertices is going to be plus 0 equal to the current color, right? So it's something like a face colors. Face colors, and this is going to be 1. This is going to be 2. And so face colors, what's the current face? So we have cube face pairs, and I suppose my brain doesn't want to visualize like these two-dimensional structures for some reason right now. So I need the number of the current cube, of the current face rather. So this is the current one. Okay, so the thing is, you can try to take y and multiply it by 2, right? I mean, multiply it by 2. That gives you sort of the current pair and whatnot, and then plus g. I think this is how we can do that. I think this is how we can do that, but on top of that, yeah, we already multiplied 3 by vertices, and surprisingly, we might as well also iterate in here. I'm running out of letters, so I'm probably gonna start using q. Q less than 3 vertices. 3 vertices plus q. So this is trees per face. So this is the first face. And here we can just use Q. So I have too many like layers of this, like something would be better to be extracted, but I think that's okay. Alright, so Q pairs Then pair components, I generate one face, right? I generate one face, I iterate through all the triangles in that face, I add that triangle to the final mesh, right? I add it to the final mesh, and also I add corresponding colors, and the colors do depend on the current face, so yeah. They do depend on the current phase. So the fact that I have 4 nested loop is not actually that important because the ends are very small, so it's not gonna affect things that much. Pair components, trees per face, and tray vertices. So that should be okay, I think. I think that should be okay. So if I try to compile this entire stuff, I think it's not gonna work, of course, because I need to rebuild everything. So we don't have our GBA here. Which is kind of interesting. So what did it say? What did it say? Did you mean GL RGB? No, I meant my original RGBA, which I forgot to include here. I just forgot to include here. I would watch you embed electronics into your tea kettle. I know nothing about electronics, and to be fair, I'm not really that interested in electronics. I can probably do that, but it's not that interesting for some reason. I don't know. Electronics have too many real-life problems for my liking. And also a very minimalistic person, and I'm not a huge fan of making overcomplicated systems, so it's quite unlikely that I will try to build something like that. Alright, so we need to have... It sounds like you're that kind of person. So in that case, I would suggest you to build this kind of stuff, but not to rope me into this kind of stuff. Alright, so cube mesh, cube colors, I suppose. This is what we can call... Yeah, this is a cube colors. And let's put it like this, cube colors. So we generated something. Is it gonna work? It still doesn't really work because missing braces around initializer. Missing. So it tells me that missing, but can I fix this error by removing braces? So, oh yeah, I know what the fuck is going on. Yes, it's a very interesting situation. So let's probably have to do it like that. Is it gonna work now? It seems to be working though. Mesh. So is it probably because it's called... Oh yeah, it's supposed to be called mesh. Yeah. So it's supposed to be called mesh, and now it should work. Yeah, it's probably because I also need to synchronize the headers. Synchronize the headers. Let's try to run it and see if I didn't break it. Okay, I didn't break it. I didn't break it, so that's already progress. That's already quite good. But we have cube colors and we have cube mesh. And what I think I want to do is probably generalize this function to accept, to basically accept the size of the buffer and the pointer to the buffer and just create like array thingy. So I'm not quite sure. Let me think. Yeah, I already remove it. Because I want it to be a little bit more abstract than it is right now. So buffer from from data. Let's call it from data. And then we're gonna have data size. And do we need to let's call it array buffer from data, right? Because we're specifically creating array buffer. Yes, so we're gonna do this kind of thing, right? I'm gonna copy paste it here, and then it's gonna be GL buffer, right? It's gonna be GL buffer. OpenGL glitches in the mod, yeah. So this is the data size, and this is going to be the data. So you cannot customize this thing, but we don't really need that for in our particular case. So this is going to be buffer ID, and let's remove this entire thing and try to, and try to migrate the current code to this function, because it's more general, right? Make -b. All right, warning, implicit. Okay, array buffer from mesh. You provide cube mesh, right? And then you need to take the size of cube mesh. Yeah. Cube mesh. Yeah. So implicit declaration. Array buffer from data. Okay. And let's actually instantaneously also run it and see if I didn't break it. Okay, cool. That's epic. So here we have gl uint cube mesh buffer ID. That's what we have here. Gl uint cube colors buffer ID. So this is another thing that we do here, which is essentially array buffer from data, and we provide cube colors and the size of cube colors. There we go. So this is the second thing that we create here. So yeah, I think I want to split this entire stuff a little bit. So after that, maybe I want to bind the buffer. Well, I mean, it's already bound if you create it like that, so you don't have to worry about it too much. So, and after we created the buffer from the cube mesh, we have to initialize vertex attrib array for the colors, right? We need to initialize them for the colors. All right, so so here's the position. In our case, the position is going to be the second one, right? Oh, we need to prepare the place for the colors, right? So we're going to have layout. Location is going to be 2 in vec4 color, right? So this is going to be the position, and this is going to be the color. And we'll have to pass that color to the fragment shader as well. So, but it's actually easy. It doesn't require modifying C code at all, so it's fine. Const gl int Anabuthu, what's up? What's up? Wanna see something cool? Oh shit. Yeah. This is what we did so far. I think that's pretty cool. Anyways, let's continue. So this is going to be the position, and it's going to be the second one. And let's enable that specific position in here. And this is going to be the attrib vertex. MCQ8 subscribed at tier 1 for 7 months. Oh my god, thank you so much for more than half of a year of tier 1 subscription, and welcome to our epic OpenGL club. How about that? Look. This is what you subscribed for. Thank you so much, I really appreciate it. Epic OpenGL skills, dab. But eventually it's gonna work okay, hopefully, we'll see. All right, so let's continue. We need to do GL vertex attrib pointer. So the amount of components we have here, I think it's gonna be something like RGBA components. Yeah, RGBA components. Right, so this is the components, and it's also GL float and whatnot. And it also accepts it as vec4. Hopefully that is enough. I'm pretty sure that is already enough. So let's actually recompile everything and see if we can get that information from the shaders. Okay, so get ready, and we're gonna do a little bit of a shader magic now. So we're already accepting some of this stuff. So let's say that the output here, to be fair, it would be kind of better to call it vertex position, I think. Does it? Okay, so it breaks something. Nice. Position. Oh, yeah. So now position is undefined. So if I try to do that, I have to do vertex position, right? Now it works. Okay. So yeah, I have a hot reloading system of shaders. That was never done before, by the way. So I'm the first one. Okay, so now we can do an output. An output is going to be something like out vec4 color, and we're going to just do color to vertex color. Color vertex vertex. So the tokenization of GLSL mod does not consider this as the end of the word, right? So for example, move word forward moves to the whole variable. You see, I'm just moving one word and it just moves between them. While it's, for example, in simp C mode, I'm pretty sure it's, yeah, it's considered the like a word separator, and you can actually move between these things. This is actually way more convenient in my opinion. So, but GLSL mod decided to tokenize them slightly differently. So here's the vertex color. Okay, so that didn't break anything, and in the fragment shader we can accept, yeah, we can accept the color, and I'm pretty sure we cannot. Yeah, so we'll have to come up with a different name for this thing. Let's call it something like frag color. So fragment color. So here's the fragment color, and there we go. So we have a fragment color. Now, what I want to do is I want to just use the fragment color for this thing. And it broke. It absolutely goddamn broke. I don't know why, but it broke. Is that because it has to be called the same thing in a vertex shader as well? I do think so. Yeah, okay. Frag color. Let's call it frag color then. And it absolutely broke. Color is undefined. Okay, what about frag color? Nope, doesn't work. And you may not know even why. You may not know even why. Okay, that's really interesting. So basically we don't have any the information doesn't go through. The information just doesn't go through. So maybe we should try to print the edges that we've got. So the color edges, let's try to print them. So we're gonna do something like this, size T. Just want to see if this thing even introduced anything. Okay, so print f RGBA FMT, RGBA arg. No, I never tried DirectX because I don't have a Windows, I'm sorry. I don't have Windows. Cube colors. It's gonna be like this. Yeah, there we go. So I'm gonna go to RGBA. I'm too poor to have Windows, so it is what it is. Oh, wait a second. Yeah, this is for RGBA FMT. Has to be something like RGBA F F F F. Might as well actually put them like this. And then we have to define RGBA arg, which will accept RGBA CS 0. Right, we're gonna start with 0, but then we're gonna copy paste this a couple of times. 1, 2, 3, 4. Then it's gonna be 1, 2, 3. All right. So let's see. So after I generated and dumped everything, I want to quit. So the rest of the stuff does not distract me from the troubleshooting. Okay, so 1, 2, 3, 1, 2, 3. That makes sense. 1, 2, 3, 1, 2, 3. Yep, that looks reasonable. I don't see any problems with that whatsoever. So the data that we have here is absolutely reasonable. I don't see anything wrong with that. So here's the position. So here's the amount of components, RGB components. Okay, so so this is position 1, this is position 2, and this all should work. Let me double check if, yeah, we keep the buffer bound. We keep the buffer bound, so there should be no problems in there. Okay, so let's take a look. So here is the vertex position, here's the vertex color, so this is what we should receive there. So we prepare everything here, and this is going to be the output. Then it goes as a vertex color, so we pass it to the fragment shader. Don't see any problems in here, and in the fragment shader, we accept so maybe, yeah, there's definitely a problem in here. Okay, so this has to be a color, and we're gonna accept it as color. Okay, so this is the color, and this is a color, and then the input is gonna be color, and color like this. I think this was the problem. Okay, I can see it now. I can see the problem now. So let me see if I can run it now. Perfect. Okay, this is exactly what I was talking about. Nice. So, and we can clearly see that there is a problem with like seeing the back, I suppose. Seeing the back. So this is clearly the problem with like Z or something. So yeah, we probably need to enable the Z, like depth buffer or something like that. I think it's called depth buffer there. Okay, let's try to fix the depth buffer. Oh, by the way, so I'm thinking we can also play with this entire shit. We can play with it a little bit. Because we have like hot reloading of the shaders. So, and we can take the color and texture, right, and mix them in some proportions. So this is the color, and we can mix them 50-50. So we can now see through this beautiful texture. Alright, so we also have an access to the time, and maybe it's gonna look okay. I don't know if it's gonna look okay, but yeah. You can do sign of time, and it's not gonna work because it's gonna be from minus, so it's gonna just look like shit. Yeah. Yeah, it doesn't really look that interesting or anything, so. Well, yeah, so this entire thing was actually useful. It revealed the problem with the depth buffer, so let's actually learn how to work with depth buffers. GL depth buffer. Okay, let's see. Advanced OpenGL depth testing. Do we really need advanced one? Because I don't really need anything super advanced, to be fair. My mouse is dying. Depth test. Oh, I do remember that. You have to also clean. Yeah. So let's actually try to just enable this thing. Oh my god, my setup is not really convenient. My setup is not really convenient. So here's the debug. We enable the debug. Do we have a special place where I enable everything? I guess I'm gonna enable everything here. I think it does make sense. Right, depth buffer. Will it just magically work if I enable it? It won't. That's actually very interesting. So if I just disable it, will it work? It will. So apparently maybe I have to clean it. As it is suggested in here. So let's actually try to enable it and clean it. Right, so we clean both color buffer and the depth buffer that we just enabled. Will it work? Yes, it worked and we fixed it. Perfect. Perfect, perfect, perfect. Absolutely goddamn fucking epic. So that's a goddamn fucking cube. So do you guys know what is a depth buffer and why the fuck it's needed and why the fuck it is important? Okay. Yeah, my internet went down, I'm sorry. So I read about the like depth buffer long time ago before I got into OpenGL 1.0, right? Fun fact, I started to get interested in 3D graphic before I even knew about OpenGL. So here's the thing, for me 3D graphics is not associated with any graphics API. For me, 3D is more like a way of thinking, I don't know, it's just math, right? You don't have to use any specific APIs to do 3D, right? So, and I read about the Z buffers, and if I remember correctly, it was a long time ago, I already forgot a lot of things, right? So essentially, you have a color buffer, right? And you have a bunch of like pixels, right? So you have really, really big pixels. Drawing these grids is actually so goddamn fucking painful. Yeah. Right, and you want to render like a triangle, right? And you render the triangle pixel by pixel, right? So here's your like triangle. Right, so you render the triangle and you filled up the pixels of the corresponding colors. I might be wrong on everything I say. Again, I actually did that a long time ago. But what's interesting is that the edges, right, the vertices, I'm sorry, they're not necessarily on the same plane. Some of them may have different z's, different z value, right? So, but the way you draw them, you basically project 3D point on the 2D plane and just interpolate by drawing a line. This is how it's usually done, right? When you drawing 3D triangle, you're not in like projecting the whole triangle. You're only projecting its vertices, and then you just interpolating the vertices by connecting them with just a straight line, and that's actually accurate enough. It's actually pretty accurate. Yeah. So the way Z buffer works, right? It takes the Z of this vertex and the Z of this vertex, and as you draw pixel by pixel, it interpolates Z from that value to that value in a secondary buffer, right? So you have a secondary buffer, and so here are the pixels, the corresponding pixels, and essentially it stores the z values of the corresponding pixels. So it keeps track of the z value of each individual pixel. So this was going to be 1, 2, and 3, right? So, and basically in the depth buffer, you have the z value of the corresponding pixel in the color buffer. So in the color buffer you have this pixel, and then you can quickly check up what is the z value of that specific pixel. Why would you need such buffer? You would need such buffer if you try to draw another triangle on top of that one, right? You want to draw another triangle on top of that one, and as you draw it, you not only put the pixels on the color buffer, but you also check the z values in the depth buffer. And if the z value that you're about to put here is actually greater than the z value you already have here, you just don't draw that pixel. You just don't draw that pixel because you know for sure it's gonna be behind whatever is already drawn. And since you do that on GPU, each individual pixel can be drawn in parallel and checked in parallel. So this is how it works according to my memories, which was a long time ago. Did I understand correctly? Do I understand the depth buffer correctly? Please correct me. I think this is how it works. Yeah, so basically it just keeps track of the interpolated z values that then can be used to, you know, not draw certain pixels according to their value. Yeah, and you don't necessarily have to do that on GPU. You can do that on CPU as well. You can just basically explicitly define color buffers and then z buffers and just do pixel by pixel yourself. What about transparency? Transparency is completely orthogonal to that, I think. Well, you just handle it, right? You just have to handle it. Just handle it. It's like asking, what about sorting the database entries? You just sort them. Like, what about that? Just sort them. So it's the same thing. What about transparency? You just handle it. So if you need transparency, you just handle it. All right. So, you just draw the rest of the owl. What's not clear? I don't understand. You draw 2 circles and then the rest of the owl. Like, I mean, how is that not clear? So you need transparency, you just handle transparency. Come on. Don't ask silly questions, okay? So, let me commit whatever we have. Introduce colors to the cube mesh for debug purposes. Okay, so and also enable depth. Yeah, we're gonna call it just depth. So now we need to do the texture. So what if I try to render the texture now? Is it gonna look differently? It's gonna be texture pog UV. I think it looks all right. I think it does look all right. So the next thing we do, I think we just need to generate UV coordinates along with the mesh, and just keep it in a separate buffer. Just keep it in a separate buffer. So. Okay, let's see. So mesh And I suppose it's gonna be just like UV, trace per cube. So this is what we're trying to achieve here. Generate cube mesh. Go see. Yeah. Tree UV. Trace per cube. So what's interesting is that for each face, we just probably need to keep track of, like, we just need to assign the same UV coordinates, right? So it's gonna be just 0, 1, 1, and 1, 1. Oh, wait a second. UV are 2D, and tree that I'm accepting here is actually 1D. Yeah. It's actually 4-dimensional, so we have to have a different, absolutely different type in here. We need to have a different type. So what kind of type we need to have? So something, yeah, we need V2 actually. We need V2. So let's introduce it. It's going to define V2 comps. It's going to be 2. Type def struct. V2 float components. I think you're setting each vertex color 3 times. I think you shouldn't think, because thinking is dangerous. So the best kind of software I've written and the most complex problems I've solved, I wasn't thinking. So I think thinking is overrated. So yeah, that's my opinion on that. Thinking is overrated. Think less and you will do more. Anyways, that's my thing to do. Okay, so let's put it this way. Query replace is going to be 4.2, and let's put that this way. And now we have this thing. My favorite song, by the way. So now I need some, I guess, like, I wish it was a template actually. In that case I would try to parameterize it by these things, but maybe it's not that important. So let's put it this way. It's gonna be V2 UVs, and you have trace per cube, right? You have trace per cube, and what's interesting is that we can try to do something like tree. Oh shit! We could have actually made it like 2-dimensional array, and I think it would work fine because the second dimension would be actually type checked properly. Yeah, I think. Yeah, so what's interesting in C is that only like the first dimension decays into a pointer. Any consequent dimensions actually don't, and they could be actually type checked properly. This is actually very interesting. So that way we're sort of like passing trees per cube arrays of the size 3 vertices. Right. So let me actually see if we can do that. So I think it works like that, and if it does work like that, I think it's gonna be very useful, because that way I would be able to get rid of this thing. Yeah, I will be able to get rid of this shit. Alright, Jia Yang, what's up? Welcome to the stream. How are you doing? How are you doing, buddy? Alright, so and then here what I have to do is just replace this thing with that, because they are not compatible anymore. Yep. And So this is just unused. Yeah, there we go. So now, what I have to do is literally get rid of that, because it's already computed automatically by the compiler because it knows this thing here. So I can just remove this thing and just replace it like that. Yes, that's perfect. That actually makes it a little bit more readable. Yep, and it's still, I'm pretty sure it still works. We can even try to check that in the caller. So the fragment. Yeah, the fragment. Fuck. Thank you, Chitarina. Very cool. And of course nobody's watching the stream right now to actually properly send that emote. Yeah, thank you. Alright, so yeah, it seems to be working, so everything works okay. For those who doesn't know what the fuck is all of this shit, so yeah, C does work like that. C does work like that. So essentially, when you, if I understand correctly, like, according to my experiments at least, right, you have like endpoints, right? You have endpoints, which is like 30, and then you have 3 components, right? So you have components. So, and only the first layer decays into the pointer. So the actual type of this thing inside of the function is going to be like a pointer to the array, to the sequence of the elements of this particular size. Right, so yeah, that's how it works. What the fuck is all of this shit? This is your message on the screen, that's what it is. Alright. I would like to have, oh, here it is. I have tea. Don't tickle me, please. So, let me do a committee. So I think I want to do it separately. Yeah, tickle. 1, 2 equals. Actually, it has to be a sender. Thank you, Chitarina. Very cool. I have to kill it. And it didn't copy paste. Okay. Let's CMD. I have to repeat it over again. You know what? I'm done. I'm over it. I just couldn't be bothered. Alright. So what do we have here? So here it is. Too much effort. Okay, make generate cube mesh return to the array of colors. And let's push that. So what we need to return here is the following thing. It's going to be v2. And maybe because of that, I'm also going to transform the tree in here, because this particular type is not that useful. We'll see. So this is going to be UVs, and it's going to be trees per cube, and we're going to return 3 vertices, right? 3 vertices. Yeah, because it's kind of similar, but yeah. So gear C. So I'm gonna put it like that. So now, how are we gonna assign all of that? I guess we just have to, yeah, generate cube face mesh. Yeah, it accepts like three-dimensional stuff, so it's not gonna particularly work well for generating multi-dimensional things. Unless you actually, well, it could potentially work with multi-dimensional things, but it's not gonna work with them. Right, it's not gonna work with them, so that means we'll have to use like implement that algorithm ourselves, which is not that difficult to implement. It's just like yeah, I need to make a small break. I need to make a small break. 2 minutes. Yeah, what's up? So I need to do the same thing for the UV coordinates. So here's the face mesh, and then I copy it. Can I actually generate it directly into here? That's a very good question. I think I want to try to do that. So basically get rid of the face colors from here. Yeah. I think it's a good idea to try to generate it like directly into that. Face mesh. Uh-huh. Huh. Yeah. Okay, let me try to get rid of the UVs and yeah, I think it's gonna work. I think it's gonna work. Alright. So the reason why I want to have that is because it will eliminate this step, which is not particularly useful generally. And I think it's going to be simply mesh count. Yeah, if I do it like that, trace per face. Yeah, I think that should work. And it doesn't because incompatible type. And what do you expect as a type? Tree, expected tree, but got an argument. Okay, so can I do it like that then? Yes, it worked. Okay, so that was actually pretty cool. Yeah, I can eliminate some of the step in this algorithm and make it more like general. Yeah, so this is not needed, so it's gonna become even more simpler. So that's cool. So wait a second, I wanna see if I enable the oh my god, i3, holy shit. Okay, so this is good. Okay, seems good. So here's that, and now I want to somehow compress this entire thing. The question is how we can do that. So we have trace per face. I forgot how C stores the arrays. At least my brain, it cannot build the mental model. So if I have something like this, n by m. Right, so yeah, it have this kind of stuff. So it's gonna be 2, 3, 2 rows, and yeah, so this is the array. The size of the single row is gonna be 3, right? My brain for a second forgot about that because I have to keep like a huge mental model in my head right now, so that's why my brain forgot about it. So and just some like I have a really small buffers. When I try to build really big mental models, some details like start to disappear, and one of them it was actually how the array lays out these things, and it happens to me from time to time. So so this is the thing. So this fills up 2 of these things, right? It fills up 2 of them, and interestingly enough, this is gonna be like, well, yeah, this is the easiest way to do that then. So it's gonna be count plus key, and then we're gonna be adding this entire, like, a 2 to this entire thing. So now we have, yeah, we added two triangles there. We added two triangles. Another thing. So I need to replicate that algorithm for UV coordinates. That's what I need to do. I need to replicate it for the UV coordinates. But this algorithm only works for vertices and for different combinations of things. So not quite sure. I'm really not quite sure. It would be kind of cool to generalize this entire thing. So essentially you would set these values yourself, but then so I guess I can do that myself. I already have this inner loop in here, put in here. It's literally the same loop: trees per face, trees per face, tree vertices, tree vertices. So I already have that, right? And so in here is the color, and then I can have UVs, and I'm looking at UVs plus K, and I'm looking at the Q's vertex there. I'm looking at the Q's vertex. And how do I generate things? Well, I essentially calculate K, and K is I plus J, but in, oh my god, so this is gonna be like T. K plus Q, because we're too much in, like, too many layers of for loop. Alright, so this is a Q, and then we have components in here, so CV, CS, this is gonna be the X, and this is gonna be the Y. Alright, so this is gonna be the X, and this is gonna be the Y. And we have to put T in here, and of course, yeah, it's so easy to make, and this is not correct because the another one has to be a shift. Another one has to be a shift, and it's so easy to make a mistake here. And it's just insane, but maybe at some point I can make it more general, so it's a little bit easier to manage. We'll see. So essentially, the idea is to put the same UVs on each individual surface. Maybe we can even copy-paste that, but I think it's just a little bit easier to do it like that. I might as well actually try to, yeah, maybe like copy-paste the entire thing there. So yeah, like inline generate cube face mesh would be interesting, I think. But anyway, so let's actually do something like this. It's going to be V2, UVs, trees per cube, and then another thing is a tree vertices. There we go. So here is the thing. So geo.h, and let's put this thing. Right. So should be okay. I think. Right, let's actually see if I didn't break anything specific. So yeah, we will have to allocate this V2 thingy. UV scholars, trees per cube, tree vertices is going to be 0 here. I think it has to be called cube UVs. Yes, it has to be called cube UVs. Cube UVs. There we go. So is it gonna... Yeah, okay, so we didn't break anything. That's already good. We didn't break anything. That's perfect. All right, so now... Didn't break anything. Oh, since we refactored that thing, maybe we don't even need to do that. Okay, that's actually Nice. Let me see if I didn't break anything. Alright. So UV coordinates. Now, after we did the UV coordinates, we need to actually create the buffer for them, right? So we generated the mesh, and then yeah, I need to prepare the location for this thing in here. Location for this thing here. This is going to be vertex UV, right? And vertex UV actually takes like two-dimensional of these things. Right? It's a two-dimensional thing. All right. Cube UVs, and this is going to be cube UVs. So the position is going to be the third one, right? So yeah, we have 3 positions in here. So here's the position, RGB components. This one is V2 components. I think that's what we need to do here. All right, so this is a V2 components, and now cube UVs. It kind of passing argument from incompatible type. Oh yeah, this is actually pretty cool. So you see, it actually checks for this. Well, I mean, it's just a warning though. Huh. Anyway. Alright, so we have unused IDs, which is very interesting, but maybe that's okay. Yeah, so maybe we don't have to store these IDs because we create the buffer and we instantly just associate it with the corresponding vertex, so we don't have to really keep track of these IDs, at least in this specific case. Right, at least in this specific case, we don't have to do that. All right, so everything looks okay. Now, if I go to the vertex, right, so I also need to output that. So I already output UV, and I suppose I'm gonna just output it as the vertex UV, you know what, I can already just keep the session, hot reloading session. So this is gonna be the hot reloading session. Yeah, let me put it this way. Hot reloading session, and just open this thing like that. Right, open this thing like that, and in here, yeah, I'm gonna just do vertex UV. Okay, that didn't break anything, and let's actually like do it like that. Okay, so that breaks everything. That means everything it works exactly as expected. Then I can go to the fragment shader, right? I accept UV. The fact that I'm without the chat is your fault, by the way. Alright, so what do I wanted to say? Okay, so here it is. We passing UV coordinates and we're using UV coordinates like that. Okay, as you can see, it's kind of interesting, but yeah, it's doing something. Slightly cursed, but yeah. Zozin, this is because you didn't do that transformation and didn't call that function. Zozin, read this article. This is because of that. Zozin, you're doing everything incorrectly. Zozin, yes, come on. Start backseating. That's literally the reason why I didn't have chat when I crashed. That's literally the reason. So yeah. Okay, so this is already something. So we're getting closer to the original thing I wanted. So let me actually first commit this entire stuff. Let me first commit it. So that's not bad, I think, for the first try. I think like this is my first textured cube that I did without tutorials, by the way. So I didn't go through a tutorial that tells me how to texture a cube because all of them are horrible, right? So, but this is my attempt at, you know, doing that. At but we can try to troubleshoot and see why the fuck it is like that. So, maybe this is because yeah, we have to also invert them because the image is not inverted and whatnot, and yeah. So, anyways, introduce UV coordinates to the party. Let's make a cup of tea. Okay, so while I'm making a cup of tea, I think I'm gonna keep it running. Yes, I'm gonna keep it running. So, does anyone have any questions while I'm making a cup of tea? Does anyone have any questions? I'm reading the chat. Go ahead. Feel free to ask questions. You use Emacs as an OS. What is OS? Let me guess, operating system. Okay, let me rephrase my question because I know what you're gonna answer. What is operating system? Why the texture get distorted? Because it's not finished! Alright, so I'm gonna go to the kitchen and turn on the kettle. We have tea leaves in here. I want to be kind of able to stop the execution, or at least the time, just to see some particular things. But we cannot do that right now, so maybe this is what I'm gonna work on. So right now we're rotating using the time, right? So we literally use time as an angle. Might as well even change it like this. So this is going to be literally time. So this is the rotation. Okay. Alright, so that didn't break anything. But the problem is that we pass the time from glfw time, glfw get time. Is there any way to stop it? I'm pretty sure there is. So who is going to be the first one who's going to Google how to stop the glfw time? Activate airship. Unfortunately, it didn't work. Don't have an airship. I tried. Well, I mean, we can define this function, I think. Works. Oh yeah, so it should be in a loop because it probably gets the data from like polling the events or something. Yeah. Activate airship. It's a pretty interesting piece of code. Thank you. Alrighty. So let me see. GLFW. So nobody has said how to stop the time yet. So I assume that it's not possible because it's actually relatively easy to Google up. So you can set the time, but you can also get the time. Yeah, but there's no way to stop the time, so that means we have to keep track of the time ourselves. We have to keep track of the time ourselves, and when we stop the time, we just don't do that. Right. So the easiest way to do that would be to introduce like a float, maybe double time, right? And also keep track of the previous time. There we go. So this is the previous time. Okay, so now after we pull the events, we do time plus previous time. Actually, glfw. Maybe we have to save it, I think. So it's gonna be double current time. Current time is gonna glw get time. Right, and we're gonna add current time minus previous time, and the previous time will become the current time, right? So that's my first idea that I have. So, and when I set the time, I don't set this time, I set this time. Let's see if that actually doesn't break anything, right? Let's see if that doesn't break anything. Okay, so we can now introduce, I think, something like post, right? So, which by default is not enabled. If not post, we just keep increasing the time, right? So, and now we need to check the following thing. So, what was your code? What was your code? Cerimon. Yeah. God damn it. So there's like a recent change in Chatterina that doesn't allow me to just keep this pop up here. As if I switch from it, like it just disappears. So what I have to do, literally, I have to copy paste your thing first. And yeah, I don't know. It used to actually stay. It used to stay, but it doesn't stay anymore. And that's kind of sad. Okay. So let's do it like this. It's gonna be equal glfw press. I mean, Jian, come on, they're doing it for free. Seriously. This is a free open source software. Like, imagine spending so much time on giving away a lot of work and effort than being read at. Even ironically, it just gets really old and frustrating. I'm telling you as an open source maintainer. I'm telling you that as an open source maintainer. Just please. Okay. I know that you're not being serious, but when the same not serious joke is repeated like hundreds of times, it just gets so old, and it's just like, come on, seriously. They're doing that for free. Come on. So if we press glfw what space, right? Space. We're gonna just toggle the pause. Yeah, so and essentially when it's paused, right, it's not gonna increment the time, right? So the time will literally stop. That will stop the rotation and any of the effects that are based on time in the shaders, right? So that's basically it's going to be the thing. За родину. Okay, cool. Sorry. Finally have a cup of tea. My favorite kind of coffee. Cappuccino. Ah, funny. Haha. Anyways. Oh. Oh, that's okay. Yeah, so since I'm doing like immediate input check, I have to do that quick enough, right? So yeah, I have to change it to callback. That's right. I have to change it to callback. So we probably need to change the pose to a global variable in that case then. I need to mark this section of global variables. Global variables. See me. Lol. No, I'm not gonna put that there. Okay. People, fragile people with CS degree, look away. Okay. So that's gonna what we're gonna put here. A very long time ago, when I was a student, I've met a person that was like a PhD in computer science in some like pretty cool Russian university, and they almost like literally had a stroke when they saw me defining a global variable. Like I thought they were gonna also kill me. Like what the fuck? Holy shit. Education like ruins people, I'm not gonna lie. So anyways. So yeah, well, we need to define like a callback, glfw keyboard callback. Keyboard input, key input. So we have to set the callback. To be fair, this kind of pausing would be very useful in the original OpenGL template, I think. So yeah. So for those who didn't see, I updated my original OpenGL template. So you can find it here if you want to. So now it has more interesting stuff. I'm gonna show you. So it's gonna be OpenGL template, and if we run this entire thing, yeah, so it has like this little animation and so on and so forth, but it doesn't support the, you know, pausing. So I think it would be nice to introduce that into the OpenGL template, so every time I start a new OpenGL project, it's already available there. It's already available there. I already see people triggered by global variables. Nice, that's very good. So I'll probably introduce even more variables, global variables. Yeah. So I think I'm gonna copy paste that stuff from my original thingy. So the reason why I introduced this comment is because it's super easy for me to find the section with global variables. So I'm just gonna copy paste it here. And also, yeah, it's gonna be Boolean pause. You see, look. I'm defining more global variables, and there is literally nothing you can do about that. And I'm gonna keep defining them. Just keep watching. I'm defining more global variables. Yeah, and there's literally if you submit a pull request that tries to illuminate global variables, I'm not gonna accept it. There's literally nothing you can do from preventing me to define global variables. Nothing. Seriously. You just have to accept it. It's just the life. Also be the PR that makes everything a global variable. No, that's a PR I will accept. No, I probably won't accept it, but that's an interesting idea. Add some undocumented magic numbers. We already have a lot of shit ton of magic numbers. Specifically in Geo, I suppose, but yeah. Alright, so let's actually repeat this stuff. So this is gonna be double time. W get time, and then we're gonna have the previous time. And the previous time. Current time, GLFW get time. And if not paused, pogged. Time plus current time minus previous time, and the previous time is going to be current time. Prime time for the current time. All right. Bashing global variables. Does it mean to like using global variables in bash scripts? Alright, so this is gonna be time. Okay, so we need to do the keyboard thingy. Keyboard thingy. So here is the... Wait a fucking second, we already handled that shit in here. Okay. So maybe I have to... Yeah, let's put it this way. If action is pressed, can I also do the switch case? Switch case is not ideal, so I'm gonna if... Look. I'm using if else instead of switch. Look at me. GLFW key space. And there's literally nothing you can do about that. Yes. And if you submit a pull request that changes this if else to switch, I'm not gonna accept it. Yeah, I'm using global variables, I'm using switch, if else here instead of switch, and you just have to accept it. There's nothing you can do about it. It is what it is, and it isn't what it isn't. You may try to do everything. Try to fix the code, try to report me to Twitch staff, nothing will work. I will not switch to switch case here. Imagine actually reporting me for this shit. Oh, I'm sorry, Tony, I had to report you. Yes. Oh yeah, the go-to is coming, don't worry about it. I mean, I used go-to like a couple of times, not a couple of times, like a lot of times on the stream. So, and to be fair, I personally don't see anything wrong with go-to. We can talk about that if you guys want. I don't see anything wrong with go-to, especially in pure C, especially when you need to handle errors. And I actually did use go-to a couple of times to handle errors in a C. Also, they make a pretty useful, like a state machine when you like parse things. It's actually pretty useful. So I didn't see anything wrong with go-to. So, and if I need to use go-to, I will use go-to, and there's literally nothing you will be able to do about that. If I need to use go-to, I'll just use go-to. Now, I won't ask your opinion. I'll just use it. Anyways, so we'll put this link here and make -b. And let's see if I can stop now. I think the animation has been stopped. And I press again, it's not stopped anymore. And I can stop it at any time. So yeah, now you can just stop the animation. That's pretty poke. And this is an OpenGL template that I use on my streams, right? If I need to like start something related to OpenGL, and that OpenGL template is available for everyone if you want to use it as well. Just keep in mind that it uses global variables, right? What is that? Is that another emote? We don't really have that many emote slots. Okay. So GLW key space. Yeah, let's do a committee. I'm gonna do this thing. Shader hot reloading. So I'm thinking, originally I wanted to have like a table with controls, but then I opted out to... Yeah, let's do the following thing. I'm gonna introduce the controls table here. Controls. So it's gonna be something like that. Key, shortcut, description, shortcut description. So the first shortcut that you can use here is KBD F5, right? So F5 reloads the shader. I'm gonna copy paste this entire thing. Reload. Yeah, reload main frag and main vert shaders. Red screen indicates a compilation or linking error. Check the output of the program if you see it. Alright, so the next thing, KBD space, right, KBD, toggle, pause, unpause the time uniform, uniform variable in shaders. Yeah. Yeah, I think that's good enough. That should be good enough. All right. Introduce toggle pose. Okay. Let's push that right into the repo. And did it push properly? I didn't see it being pushed, and it didn't work. Nice. I wonder why. So, GitHub Markdown, yeah, GitHub Markdown. Table. I'm pretty sure. I don't quite remember why it was like that. Okay, so I remember that in nothing, I had a table. Yeah, here is the table. So let me go to README. And let's take a look at the raw version of this thing. Yeah. Do I have to like put... do I really have to do it like that? Okay. I guess I have to do it like that. It's kind of dumb, and the fact that it wraps around is not helpful. Wrap, toggle wrap. Toggle... Yeah. Okay, so I remember that Markdown mode can actually handle that for you. Try to fix table, I guess. And let's push that right into the repo. So let's see if it's gonna work now. Yeah, it kind of worked. Okay, kind of worked. All right, so yeah. I'm gonna add more functionality to the OpenGL template. So if anyone needs it, you can actually check it out here. All right. So now we have pause, and the reason why I wanted to have pause is because it will probably help me to troubleshoot what the fuck is going on in my original thingy here. So here's the pause and key. Yeah. So let's go back to the OpenGL example. Main.c key callback. Where is it? Really, it's not an example. It's actually a template. It's actually template. Key callback. Right, and I'm gonna just copy paste this entire thing in here. Oh, I'm a little bit dizzy for some reason. What the fuck? Alrighty. This is not what I wanted. I wanted to, yeah, make -b. And now we're able to. Oh yeah, I forgot to remove that thing. You okay, Mister? I'm not okay, but I've not been okay for a very long time. Nothing changed recently. I haven't been okay for quite some time already. For more than like a year. So I'm definitely not okay. All right. So there's like on the border. I really like how it looks like. What the fuck is this shit? Yes. He has issues. Yes, exactly. That's exactly the situation with me. I do have issues. Looks cursed. Yes, it is. Yeah, so if we used like if we used strips, would it be better though? Triangular strips. But anyway, yeah. Introduce posing. So yeah, we're still trying to texture the cube. Let me try to output the UV coordinates and see if we didn't do major fucky wacky. So it's gonna be main.c. So we generated the whole thing, and I'm gonna take this entire stuff. Oh my god. Chelovchik. Thank you so much for 100 bits. Thank you, thank you, thank you. Really appreciate the support. It means a lot to me. All right, so it's gonna be trees per cube plus I for J0 three vertices, and let's try to print all of that. It's gonna be V2 FMT. It's gonna be like that, and cube UVs I, G, and there we go. And this has to be actually V2 arg. This is a V2 arg cube. Didn't really compile properly. I know why. So, okay, so let's actually exit after we print it, because I don't want the main program distract me from reading the output. Okay, so... Okay, I fucked it up yet again. I wonder why. So in geo.h, so when I have v2... Oh yeah, I see. Very funny. Emacs. I think it's not Emacs, I think it's something with my keyboard. Sometimes it just doesn't register my presses. It's like really strange. I don't quite understand it. Like, okay, so 0 0 1 0 1, yeah. New keyboard soon. No. That's for sure. That's for sure, for sure. So there's something, like, we already saw this kind of problem before. We already actually saw it. In the vertices, right? If I go to the fragment shader, and I put it like that, vec4 uvx uvy 0 1. Yeah, main.c. That's what's interesting. Like, you don't have this thing when it faces you right away. The more you start to transform that, the more like this thing appears. And I think that what contributes to the distortion. I think that's what contributes to the distortion. I wonder what exactly is going on. I wonder if it's... So I want to try to use strips instead of like triangles, but how can I do that? I cannot easily just refactor the whole thing. Cannot just easily refactor the whole thing. So I'll have to do something else. So yeah, maybe using strips would actually help with all of that. Yeah, we should try strips. But can I quickly refactor all of that to use strips? That's a very interesting question. I need to know if I can. I wanna like try a single face. Right, I wanna try a single face. So with a single face, yeah. All right. So I think we're getting closer to at least like texturing things. At least texturing. Maybe we can even have some quick lighting as well already before we finish texturing actually. All right. So if we have something like this, right? If we have something like this. I'm gonna do a fragment, fragment. So let's go to here, I suppose. So this is gonna be the texture. And so in a game that we did like 3D games some time ago, Pio 3D, right? This is what we used. So we mixed together. So this is the frag coordinate. Can we actually use that for a quick lighting? So yeah, so this is gonna be like this, and maybe we can actually set it like that and see if it works. And it literally did nothing, but it didn't break at least. It didn't break at least, so yeah. So it probably works on bigger coordinates. This one wasn't big enough, I think. But we do have like a Z, don't we? Do we have a Z axis? Yeah. Yeah, it actually does something. So essentially, can we use Z to shade according to how far away it is? Just super quick. So the bigger the Z, so something like this. So here's the texture. Then that, and the bigger the Z, the more like it will appear far away. And of course with the Z, well, yeah, that works. Kind of. It's a little bit creepy, but it works. So that's pretty cool. Now, let me see if I can, maybe we can even add a little bit of like a reddish fog. This is creepy. Oh shit. Oh shit, I wanted to put a 0 here, yeah. I like that. I think it's cool. So if we remove the distortion, right? If we remove the distortion, it's really fucking creepy, by the way. What the fuck? Right. Right. It works as well. Can we rotate by something else? For example, Z, Y, right? Z and Y. So this is gonna be X to Z. Oh fuck. Yeah. X to Z, Z to Y. Y, Y, Z. Yeah. That's even better, by the way. Zozin, you're doing it incorrectly. You shouldn't do things in shaders. You shouldn't do them in shaders, Zozin. You don't understand. Ah! You shouldn't do things in shaders. You shouldn't define global variables. You shouldn't do that. You shouldn't do this. Ah, Zozin, you do everything incorrectly. Oh, holy shit, I like that. This is actually pretty cool. Zozin, you will never become a game developer. Stop doing things. Stop. I really like this, by the way. Oh, this is even better. Holy fuck. Yeah. What's up, Valentin? Welcome to the stream. What's up? What's up? Chat. You shouldn't do things. All right. Cool. I guess we edit like a very simple. It's not really lighting, but it's. Nah. Shading. We're gonna cheat a little bit. I'm gonna say it's shading, and I'm gonna check out this thing. Alright, cool. Introduce simple shading to the cube. Don't worry, I'd get nothing done anyway. Yeah. Fog equals shading. Yes, I'm a professional game developer. I shade things with fog. Nice. Cool. I really like the results. It's kind of creepy, but I think it's kind of cool as well. So I'm gonna push that right into. I think I already pushed that thing. Okay, so you can find the source code of what we've done here, if you're interested, of course. If you are interested. Okay, good. What the fuck? I kind of want to continue doing things, but I lost all of my motivation. You're doing everything wrong. People kind of ruined my entire motivation for today, so... I want to convert everything to a single thing. Alright, let's make a small break, and after the break, I will see if I want to continue doing this shit. So 3 minutes. Right. Let's make some break. You guys have fun. The fuck is going on? Does anyone need to be timed out? Why the chat is filled with this shit? Alright. So what I was doing, I forgot what I was doing actually. Forgot what I was doing. Let me see. I mean, we can just remove projection, but the question is why projection would affect it like that. Cry of fear. Wait a second. Oh, I think I... Huh. Alright, so I think I had enough for today, so I think I'm gonna call it a day. I'm really lost motivation to work on this thing. It was really difficult 2 streams for me to keep myself motivated because chat is just so unbearable, holy fuck. So yeah, I'm not sure if I'm gonna continue working on it on the stream, but yeah, we'll see. Probably gonna do that off screen. It's just like impossible to work on. People are just so goddamn annoying. If anyone is interested in whatever I've done, yeah, you can find it here. I'm probably gonna finish it off screen, and focus completely on this entire thing. So this is actually was part of the series that I was planning to do, but I'm not kind of sure. Not sure if I want to continue this series because it's just really difficult to do that. And it's just not worth doing it if chat is gonna distract me so much. Oh my God. The idea is that I'm gonna implement like a control application in OpenGL with a rotating cube to see what it takes to implement that, and then I want you to implement the same graphics but on CPU. Completely. So I was thinking how can you implement something like that without OpenGL, but after working on this project I don't want to do that. Seriously, I just don't want to do that. I just don't have the motivation. But in any case, thanks everyone who supported me and subscribed and donated and stuff like that. You made these streams a little bit more bearable, so I really appreciate that. And unfortunately, it is time for me to go. Thanks everyone who's watching right now. Really appreciate it. Have a good one, and I see you all tomorrow. Maybe, I'm not sure. I really need a break. So tomorrow, according to the schedule, we're going to be doing the virtual machine in C. Luckily, nobody understands this project, so nobody can backseat it completely. So usually I can get some work done on this project. So check out our schedule page to learn about different projects we're working on. Check out our VODs channel where we upload all of our recordings, and check out our Discord server for offline discussion with the community. And yeah, that's it for today. Thanks everyone for watching. Love you all.